Amusement parks are surely a great place to have fun because of its thrilling and exciting rides. They build roller coasters, pendulum rides, water rides, drop towers, swings, and of course the classic, Ferris wheel. But have you ever wondered what is the physics behind these rides? Join us on a journey filled with our daily physics encounters that we often miss on our busy lives. We are in search of the simplest ideas where you, yourself, can do and be a part of the growing community that is aware and informed. One of the simplest applications of physics is a pendulum. It is a device where a weight is hung from a fixed point so that it can swing freely backward and forward, like a traditional clock mechanism. In this example, we will show you the physics behind it and further solve the period of the system. The pendulum we have made has a length of 30 centimeters or 0.03 meters with the acceleration of gravity on Earth that is 9.81 meters per second squared. And now we will compute for its period in seconds. So starting the problem, period will be equals to 2 pi times the quotient of 0.03 meters over the gravity on Earth that is 9.81 meters per second squared. Then we have to raise it to 1/2. This gives us the answer of 0.109877 seconds. This means that for every forward and backward motion of the pendulum, the time it takes to make a full motion is 0.11 seconds.
With the use of physics, it is possible to take a building's measurement with only a barometer as your equipment. This is how its science works. First, get the barometric pressure from the ground of the building. Next, go to the building's rooftop and then get the barometric pressure using your barometer up. In this way, we will use these two pressures to approximate the height of the building using the Pascal's principle. In this experiment, we will try to measure the height of the Belief Hotel located inside the historical Intramuros, Manila, using only a barometer and the application of Pascal's principle. Based on the barometer app downloaded from the App Store, the pressure on the ground reads 101.325 kilopascals, while the pressure at the rooftop of the building reads 100.971 kilopascals. In order to utilize the Pascal principle, we have to get the difference between the two pressures, which we'll call delta P. Divide delta P all over the density of the air on Earth, which we will call raw air, multiplied to the gravity of the Earth. After computing for the height of the building, we got a result of 29.49 meters. That's how we find the altitude between two different barometric pressures.
Being informed always comes in handy. We often observe car crashes without really knowing the science behind it. In this last example, we will discuss what takes place when a car crashes a wall. Suppose that a person is riding his sports car and due to overspeeding, he loses control of it and accidentally crashes a wall. The sports car has a weight of 1,500 kilograms and hits the wall. Positive x-axis is to the right, and before the crash, the vehicle decelerated with a value of negative 15 meters per second. After the crash, it bounced back with a 2.6 meters per second speed. Now we will find the impulse the car has received and the average force of the car. So let's assume that the force exerted by the wall is larger compared to the other forces. Gravity and normal force are perpendicular and do not affect the horizontal momentum. So starting the problem, P1 is equals to mass times V1, and that is equals to negative 2.25 kilogram meters per second. And P2 is mass times v2, and that is equal to 2.64 meters per second. Now, solving for the impulse, simply get the delta P, and that is equals to 2.64 times 10 raised to 4 kilogram meter per second. So now, we will solve for the average force on car. Divide delta P all over delta T, which was given in the problem. After this, we will get an answer of 1.76 times 10 raised to 5 Newton. Imagine that amount of force. It is almost 118 times larger than that of the sports car's actual weight. This will cause severe damage to the car and most probably major injuries to its driver. From a handmade pendulum, to useful estimation tools, and to the science of a car crash, our little physics adventure comes to an end. We hope that you learned and had fun with us along our journey as curious scientists. Thank you very much for watching, and may the force be with you.